Hi, so in this screencast, I'm going to be telling you a little bit about regularization using neural networks in keras and R. In the last screencast, we were talking about how the number of hidden units is a regularization parameter. And so in this script, we did this future lapply, basically parallel for loop over different numbers of hidden units here. And we specified this using units equals hidden units in the layer dense object. So now what I would like to do is I'd like to explore how the number of hidden layers is also a regularization parameter, right? So in the previous screencast, we were just analyzing different numbers of hidden units in a single hidden layer. Now let's try the converse, a fixed number of hidden units in each of several variable number hidden layers. So how would we code that? So let's just copy this whole code block, and here I'm gonna create a new section, analyzing number of hidden layers. So this is another property of the neural network that we don't know what is the optimal value in advance. And the values that we should investigate here, let's change hidden units vec to hidden layers vec. And so this will be, say, let's try between, how about just one, yeah, how about just between 1 and 10? How about just 1 and 5 to start out with? That's already a lot, I think. So then hidden layers, new. Well, actually, let's just do a find and replace. Let's replace all of the units to layers, because in this code, we're going to be analyzing hidden layers instead of hidden units, right? So then we're going to have hidden, it says layers metrics list not found. So let's initialize this layers metrics list as an empty list, which we're going to be using to store all of our train invalidation, subtrain invalidation error curves, yeah? So, doing that, so now we've got this function, which is a function of the number of hidden layers. So how would we alter this code if you wanted to add another hidden layer? Right, so, it's a bit tricky here, but what we need to do is we need to kind of alter this model definition here. So, what we can do is, let's take this apart. So instead of having just one single layer dense here in the middle, what we're going to do is we're going to have several. And actually, you know what? We can actually consider 0 hidden layers too. That's a linear model, and so that actually is meaningful to consider. So why don't we try that? But so for the most interesting example for prototyping this code, let's set hidden layers equals 2. So how would we make this code for 2 hidden layers, right? So here, this is not, okay, it says layers equals hidden layer. That doesn't make sense, right? So here actually it should be units equals something. So let's say that there's 10 units in each layer, or I don't know, for simplicity, why don't we actually, yeah, let's just do 10 to start out with and see what happens. And let's give it a ReLU activation function in each layer. And so now what I'd like to do is, here, let's start out by just defining a keras sequential model. Starts out with nothing in it. And then after that, you know, what we can do is we can call it layer dense model. And what is that's going to do, I believe that's going to actually add that model to that layer in place. Let's see if that works. Right, so now we have a model with a dense layer after executing that one time. And now let's say layer dense again. And so now what it says is output shape is 10 in both cases, 100 parameters in the second layer, 570 parameters in the first layer. Okay, so that makes sense. So what happens is every time we call this layer dense function, it actually edits this model object in place. So all we have to do is now just do a for loop for right, so you have to be careful because yeah, I guess maybe we can actually do yeah, because yeah, the thing you have to be careful about is because the hidden layers, it can be 0 as well. Right, so maybe we can say for layer I in 0 to hidden layers. Right, so that's going to be a for loop over all of the hidden layers, and that's going to add a layer each time, and then after that we're going to add a final output layer. So when we do that, we're going to get the argument units is missing with no default. Right, that's because here we need to tell it that we're adding it to that model that we created up there. So let's try that again. Now what we get is a model with 9. Is that right? Actually, that's right. So the numbering is a bit funny here, but the architecture of the network is correct. So here in the first hidden layer we have 570 parameters because 10 hidden output units and 57 input units. Then we have 10 units in each other hidden layer, and finally at the end we have right. So actually we're off by 1 here. So here we have 3 hidden units. These are these 3. Sorry, 3 hidden layers. These are these 3 lines here, and we have so actually, so here we're going 1 too many times. Right. So here what we can do to avoid that, let's say for layer I in 0 to hidden layers -1. So what that's going to do is it's going to subtract 1 from that sequence. So we're going to do everything except for the first one, because when there's 0 hidden layers, we don't want to count that as hidden layer. So here, redoing that, now we have something that looks like what we want. Here we have the first 2, which are hidden layers, and the last one, which is the output layer with 1 unit. So what happens if we compile that model and we fit it? Let's try to fit it with 100 epochs, and let's see what that looks like. Again, we're going to be doing this with lots of different numbers of hidden layers, and we want to compare what is the generalization ability of the models with a different number of layers. To answer the question, well, should we use no hidden layers? Should we use 1, 2, 3? That's another tuning parameter in the model architecture that we have to figure out. Anyway, so now let's plot this result that we have after the model fit. And so that looks okay. The training error is going down in general, and validation error is going down and then going back up. So yeah, I mean it's not convincingly going down a lot, the validation error, but it's more or less what we want to see. It says that a small number of epochs is good for this neural network with 2 hidden layers. Okay, so thanks for listening. to this tutorial. In the future tutorials, we're going to go over how to do this for lots of different numbers of hidden layers.